Works. There we go. So we're looking at angles of elevation and depression. Okay? So to make a field goal, a kicker must kick the football with enough force and at an appropriate angle of elevation to ensure that the ball will go through the goal post. This angle changes depending on the placement of the football from the goal post. Okay, so that kick of the football as it goes through the goalpost makes an angle of elevation from the ground up through that goalpost. So first off, just to remind you what each line is, we have a horizontal line. Okay, so if I ever say find the horizontal distance, you're looking at this horizontal line. Okay? If I say find the vertical distance, you're looking at a vertical line. Okay, so that's the line you would try and find, that vertical there. So an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. Okay, so if I have an observer or this person here, okay? Yep. This person's line of sight is your horizontal. Okay, so you'd have this line of sight horizontal from where they're looking. Okay? To make an angle of elevation, you need an object above that horizontal line. Okay, so not that you should look into the sun, but if the person was looking at the sun, okay? Or the moon. I'm going to draw a sun. You can draw a moon. Okay, so if a person was looking at the sun, okay, so to that sun there, to the top of it, that would make this angle of elevation here. Okay, so when it says angle of elevation, it's always the person looking up to an object. Okay, the angle made from their horizontal, off of their eyesight, up to that object. You can see that angle formed there. Now an angle of depression is the angle formed by a horizontal line, so we still have that horizontal line, and an observer's line of sight to an object below that horizontal line. Okay, so now this person is looking down at something. Okay, so if I have this cliff here, okay, and I have this person standing on that cliff, just because, their horizontal line again comes right off their eyesight there. Okay? That horizontal line is always from their straight eyesight. Now say they're looking down at a car. I'm not going to draw a seagull. This is the car. Okay, so say they're looking down at a car. Okay, they would be looking down this way towards that car. Now the angle that you're looking for the angle of depression, okay, is the angle between that horizontal line and their line of sight. So that would be this angle here. Okay, it's not this angle. Okay, it's not the angle from the vertical to their line of sight. It's the horizontal line and their sight to that object below. Okay? Questions on angle of elevation or depression so far? All right, so horizontal lines are always parallel. What does parallel mean? They're never going to intersect. Okay? Parallel lines will never intersect. So horizontal lines that we draw in are parallel to each other. Now that means that the angle of elevation and angle of depression are going to be equal to each other. So in the picture at the left there, I know it's a little bit hard to see, but there is a guy standing right here. Okay, and there's a guy standing up here. So their horizontal lines off of their eyesight are those dashed lines there. Okay, those are your horizontal lines. Now the guy up here is looking down at the guy down here. Okay, so your angle of depression would be this angle, okay, between that horizontal and that line of sight to the guy below. Now the guy below, his horizontal's here, and he's looking up at the guy above. Now that would be your angle of elevation right here. Now since those horizontal lines are parallel, your angle of depression and angle of elevation are going to be equal to each other. Okay? Those are alternate interior angles. Do you remember those? Okay. They're alternate interior angles, so they are congruent to each other. Okay, they're equal. So just remember, angle of elevation will equal the angle of depression. So looking forward here, we have, yes, I know, it's word problems. Okay, I'm going to help you through it. Okay, so example 1. Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? Okay, so first thing we want to do is kind of make a sketch of what's happening. So we need a castle and we need our person. Okay, so it doesn't have to be the greatest castle in the world. Okay, this is my castle. I'll draw on some windows. Is that better?
No, that's hard work.
Yeah. All right. So, doesn't matter. You could just draw a house for your castle. It's fine. Okay, so here's the castle. Now, Leah is, we don't know how far away. Okay, because that's what we have to find. So, we're going to just put Leah over here. Okay, so Leah's over here. Now, I want to label my picture. Okay, so looking back at this problem. So Leah knows that the castle is 190 feet tall. Okay, so I can label the castle here. So from the top to the bottom is 190 feet. Okay. Now we also know that Leah is 5.5 feet. Okay. Now, if we're talking about an angle of elevation, that means she's looking up at something. Okay, angle of elevation is looking up. Okay, so she sights the top of the castle. So we're looking, it's not going to be perfect. So from Leah to the top. Okay, she's looking up to the top of that point of that castle. Now remember when I said the angle of elevation is between that horizontal and the sight where she's looking? So from her eyesight, we have this horizontal line. Okay, that angle created from that horizontal line and her eyesight to the top of that castle is 38 degrees. Now, if I'm looking over at this castle, this horizontal line doesn't extend all the way down, right? So how could I find this distance here? From the top to where Leah's eyesight hits if she were to look straight ahead. Yes. So to find this length, you're going to take your castle height, okay, of 190, and you're going to subtract Leah's height from it. Yeah, okay, this is roughly, okay? So from the top of her head. Yeah.
If I ever saw somebody looking like that, I'd probably run.
Yeah.
I'd be gone.
So this length or height of this castle then from the top of her head would be 184.5, okay, feet. Now, do you kind of see this right triangle formed in there? So if I look here, all right, this is your right triangle that was formed. Okay, so if you can't see it or it's hard because your picture gets in the way, what I want you to do is take that right triangle and redraw it off to the side. Okay, so I know I have this triangle here. Now this angle is 38 degrees. That would still be this angle here. Okay. The distance right here, up and down, that vertical, we found to be 184.5. Okay. We know it is a right triangle. Now in the question, it wants us to see how far she is from the castle to the nearest foot. Okay, how far away she is. So what side of that right triangle would that be? The bottom one, right here. That horizontal. Okay, so that's what we need to find. So I'm going to label that side as X right here. Now, what's one way we could solve this? How could we solve to find that side? What type of triangle is this? It's a right triangle. Okay? We have one of our acute angles in that right triangle. Okay? It's not a special right triangle. It's not a 30, 60, 90. Okay? It's 38, 90. But we can use SOHCAHTOA. Thank you. I didn't hear you. Sorry. You're too far away. So, yes, I can use tangent. Okay? From this angle here, you have the opposite side. And we want to find that adjacent side. So we have O and A, which is tangent. So I want to take tangent of the angle I was working with. Okay, so that's 38. That's equal to our ratio of side. So we have O, 184.5, over A, I labeled as X. Okay, when I have a problem like this and I'm trying to find one of the side lengths, you always multiply by whatever's in the denominator. Okay, that's X in this case. So I'm going to multiply both sides by X. They cancel out on the right. So we have X times the tangent of 38 is equal to 184.5. Now what do I do to get X by itself? Divide by the tangent of 38. Okay, so they cancel out over here. So we have X is equal to 184.5 over a tangent of 38. And you can enter that into your calculator then. Okay, you should get x is about 236.15. Now, back in the directions, it said to the nearest foot. So, yes, she is 236 feet away from the castle. So, yes, this lesson is word problems. So, when you're working with word problems, you need to pick out all of your information, okay, that they're giving you. You need to draw a picture, and you need to label it. Now, with these word problems, you should always have a right triangle that's formed in your picture, okay? So you'll always end up with that right triangle. Any questions on example 1? All right, flipping over here. Example 2. Okay. At the circus, a person in the audience at ground level watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off. That's supposed to say ground, not round. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat's head is 27 degrees? Okay, so when I go through problems like this, I kind of underline stuff that I need to know. So I know I have an acrobat on a platform, right?
Yep.
So I'm going to draw this platform in. I'm just going to draw it like this. There's an acrobat on top of that platform. So we're going to draw that acrobat in. Okay, we know we have an audience member somewhere in bleachers. Okay, so audience member we'll put over here. All right, so I underlined that the acrobat is 5'6" tall. How many inches are in 1 foot? 12. So 5'6", what is that? Half. It's half, right? So this acrobat will be 5.5 feet tall. Okay, so our acrobat is 5.5 feet tall. Now the platform that the acrobat is standing on is 25 feet off the ground. 5'6" inches. Yep.
5.5.
Because inches, you have 12 inches in a foot. Okay. So platform 25 feet off the ground. So from platform to the ground, that's 25 feet. Yes. From the horizontal line off of that audience member, it's supposed to be on the ground, by the way. Okay? They are looking up to the top of that acrobat's head. So that is talking about your angle of elevation. Okay, that angle of elevation is 27 degrees. So if I'm looking from the bottom of that platform, right, to the audience member, up to the top of that acrobat's head, what is that total length? That's 30.5 feet. Okay, again, you're looking for that right triangle. Okay. Now, in our problem, we want to find how far the audience member is from the base of the platform. Okay, audience member, how far they are from the base of that platform. So we're looking for that horizontal distance again. Now that I have this picture kind of drawn in and I know the lengths, I'm going to redraw a right triangle off to the side just so it's easier to look at. Okay, it doesn't have to be smaller. You can draw it the same size. I just tend to draw it smaller. So with this right triangle formed here, that vertical length we have as 30.5. We're trying to find that horizontal, so that's our x value. And our angle of elevation was 27 degrees. And again, that platform should be with the floor a 90-degree angle. So it does form this right triangle here. So yes, I'm going to use SOHCAHTOA again, and it is tangent. Okay, so from that angle, we have our opposite side and the adjacent side. Okay, so tangent. So we're going to take the tangent of the angle we were going from. So tangent of 27 is equal to the opposite side is 30.5 over the adjacent side I labeled as x. What's my next step? How do I solve for x? What's my next step? Multiply by x. Good. Okay, so I'm going to multiply both sides by x, so they cancel on that right side. So we have x times the tangent of 27 is equal to 30.5. Okay, I need x by itself, so I'm going to divide both sides by tangent of 27. So they cancel out on that left-hand side. So we have x is equal to 30.5 over tangent of 27. Okay, and you can enter that into your calculator. So x will be about 59.86, right? Feet. If you wrote about 60 feet, that'd be fine too. Just rounding up. Questions? All right, last example here. So a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person? So in this one, we have an angle of depression. Okay, before where we were looking up to something, that's an angle of elevation. This time we're looking down. Okay, so search and rescue team, we need a helicopter. Okay, we need some water below. Okay, helicopter doesn't need to be perfect. Again, this is my helicopter. Okay, we know they're getting people from a boating accident, so I'm going to draw water below that helicopter. And I know there's a person still in the water. Okay, so here's my person in the water. All right, now what I want to do is go through the problem again and see what information I have. Okay, so I have an angle of depression is 42 degrees. I have the helicopter is 18 feet above the water. And I want to find that horizontal distance. Okay, so if we're talking about an angle of depression, okay, again, it's going from the horizontal, okay, and looking down. So since we're talking about an angle of depression from the helicopter, because they're looking down to that person, we need that horizontal line off the helicopter. Okay, so that horizontal line off that helicopter. Now that helicopter is looking down to this person. Okay, now that angle created is your angle of depression. Okay, so that angle between that horizontal and the line of sight. Okay, that angle is 42 degrees. So we can label it as 42 degrees. Now the helicopter is 18 feet above the water. Okay, so our helicopter here is 18 feet above the water. And we want to find the horizontal distance, okay, from the helicopter to that person, right? So if I'm looking for this distance here, and I know I drew it below the water, but that's fine. Looking for that horizontal distance. Can you kind of pick out the right triangle here? Okay, there's one here, right? But I have my angle up here, correct? Now what if I were to draw in another line right here? Wouldn't that kind of make a rectangle? What would this length be right here? 18. Right? So that helicopter is still 18 feet above the water. Okay? Now if I labeled this distance as x, this distance up here would also be x. And that vertical and horizontal create that 90-degree angle. Okay, so I found this right triangle here. So again, I'm going to redraw that without all the fluff around it. Okay, so my triangle I'm going to redraw this way this time. Lift it up. With my right angle here. That horizontal side is x. That vertical side is 18. And my angle is 42. And again, I want to use SOHCAHTOA. Okay? So from my angle, I have an opposite and an adjacent. So I'm going to use tangent again. It's not always tangent. Okay, sometimes you have to find like where the ball is going. Okay. So I have tangent of that angle is 42. That's equal to my ratio of sides. So the opposite side is 18. Over the adjacent side is x. And again, I'm going to multiply both sides by x. So I have x times the tangent of 42 is equal to 18. Divide both sides by tangent of 42. So I get x is equal to 18 over the tangent of 42. Again, plug that into your calculator. Okay, I got x is equal to 19.99. So I just wrote about 20 feet away. Okay, so any questions given angle of elevation or angle of depression? Again, it has to be from that horizontal. Okay, horizontal and then looking down or horizontal and up.